Perfect. Thank you very much. So, my name's Tyson Soutter. It's Scottish. I'm based out of Italy, work for a company called Clockworks Analytics. If you are wondering, this is not an Italian accent. I am originally from Australia. I have worked all around the world on things such as digital twins, automation, integrations, FTD. All of these are terms to do with technology within a building. Today I'm going to talk about data-driven operations and maintenance. And it doesn't really matter what technology you talk in a building. What matters is, just like we heard, you understand what you want to achieve. And that will really determine and dictate what you need to do to be able to enable that. So, if you talk about any building technology, be it a BMS, be it an AV system, be it energy metering system, you're going to have to solve two problems: connection and structure or modeling. How you achieve this will limit what you can and can't do. When someone says they can come into a space and connect to a building in a single day to provide a full FTD solution with analytics and machine learning, that's not possible. What they can do is they can connect to data and understand what's happening, but there is a lot of static information, a lot of context to a building, which requires a lot of understanding and iterations. We'll talk about connectivity, but eventually that has to lead to interoperability. And these things are very different. So, it doesn't matter what solution you're using. I'm going to talk about a generic one today, but what's important is you understand how you get information out of a building. We are in a bit of an unfortunate state of affairs when it comes to standards and consistency of availability of information. On a brand new building, you might have more luck with this, but for any solution to work at scale, it requires the ability to work with the majority of assets. 99% of assets already built. So you have to understand, how do I get the sensing data out of a building, which is only a part of the solution, but in a way that I can work with the majority of systems. No solution out there can solve all of this, but if you can focus on the majority of integration methods, the standard integrations are BACnet, Modbus, OPC, it could be REST API. These are all protocols our industry's been living with for a very large amount of time, and it's the majority of buildings. Now, very technical, but these are the things you should be looking for at a high level if you want to even start talking about running a building remotely. You have to be able to talk to these systems. Now, it doesn't stop just by pulling the data from these systems. It means I have to understand it. If I'm an engineer, if I'm a technician, if I am a facility manager, I know that I have the context of how a building works. I know the temperature sensor on the wall has a relationship to the chiller on the roof, and there's 22 steps in between there. I need to be able to digitally map that in a form that a tool can use. Digitize that knowledge so it's understandable not just for an engineer on site, but for a software solution at scale. And we talked about the live data. I'm going to give an example of an air handling unit. And I use air handling units because it's pretty universal, but the HVAC systems in a building are the most complex. It's 70% of your energy consumption for base building, 40% for your overall. This is where you build the business cases for any solution around data-driven operations and maintenance. Now, if you look at what is an air handling unit, naming conventions matter, standards matter, but if all I can tell you is it's an air handling unit and this is the number, that is not enough information for me to do any sort of automation or analytics. And the terms analytics, alarms, fault detection, machine learnings, these aren't a solution in themselves. These are tools as part of a solution. That's something that you always need to remember. So, we talked about the sensing data, very important, but there's a static information that lives within a building, and this can be taken to any service within a building. You need to be able to understand what is the design parameters that I'm looking for. What was the purpose of this piece of equipment? Was it designed to work in a laboratory, or a hospital, or a university, or a commercial office building? These are all very important bits of information that will dictate on what the piece of equipment is supposed to do. And if you want to replace maintenance, it's not good enough just to say it's not working efficiently or it's not working correctly. It's not working to the design. And that's a very difficult thing to do if you're just looking at sensing data. Impossible. So you need to know what is the purpose of this piece of equipment. You need to know what is the size, the capacity. What is it meant to be doing? Because how else can you automate cost calculations? You can't. Not accurately. Unless you have a very intense sub-metering program, which is very much cost prohibitive, and again, ruling out the majority of buildings. So once you've done these two things, and I will argue that any technology in a building has to solve these two things in their own way. How they solve it will directly tell you what they can do and what they can't do. And the majority of companies today are solving this in a very selfish manner. They're solving it in a way to solve their problem, not to solve the problem of understanding how a building works and digitizing an asset. So standards like haystack and brick are very important for the building industry, but they need to be expanded. They need to be widely adopted. I think if you have a standard, if you have consistency, that's the first step, and there's ways to incrementally get to a common standard across a building, but you need to have the intention of opening that data up, not just to a Siemens, a Honeywell, or a Clockworks, to anyone. So the solution has to solve the problem for them and everybody else. The only way to test that is interoperability, which I'll talk about at the end here. Now, this is how we take data, we structure it, so now it's machine readable. I could talk an hour just on data modeling, but no one wants to hear that and no one really cares. But it's very important. So from there, we diagnose that information. If you want to do data-driven operations, they have to diagnose that information. But if you have a solution that's a digital twin, you're using those same two steps, but you're using it for a different purpose. If you're a single pane of glass, or if you're doing an ESG solution, or if you're doing a metering solution, they had to connect the data, they had to structure the data or model, and then they use that information for something. We use it to analyze that piece of equipment. So it takes into account what is the data structure, not just a data point is a temperature sensor, or a fan is a fan command is a status. But what is that characteristics of those data points? How does this relate to a piece of equipment, to a control methodology? How can I find a status for a piece of equipment without always depending on the exact point that I want to see? That's not possible unless you understand the attributes or the metadata of the systems that you are looking at. From there, now you can do what's called root cause analysis. And this is only possible if you understand the relationship between every single component in a building. It's impossible to get to the root cause of a problem if you do not understand the relationships of every single piece of that system in a building. So you have to understand that. And then, what can you do? You can run performance checks, you can do analysis, you can ensure that that piece of equipment is running effectively, consistently, and you can do this remotely. The majority of checks in a system that's done today with traditional maintenance, 30 to 40% of those can be replaced with a digital offering. This depends on what country you're in and what maintenance you use, of course, but there's a huge opportunity for savings, and not just savings, but a consistent level of performance that cannot be guaranteed when you have a human element involved. So, it's all about understanding what is the problem at the lowest level. This temperature sensor failed, this problem occurred. How does that then relate to a bigger problem? How does that then relate to the overall operation of that building? And this is something that can't be done with just simple fault detection. It has to be done at scale with a very robust data model. So once you get to this point and you're analyzing this and you're finding the root cause like we're going through here, you can start seeing that we're not just looking at one problem, we're looking at many. And how do they relate to each other? It's analysis on top of analysis. And this is how you get to that root cause of a problem. The most important step and the most difficult to achieve. Without this, it's impossible to do accurate cost calculation. Because if you imagine a scenario where you don't understand the relationship of every piece of equipment in a building, when you do a cost calculation on a main problem that affects more than one piece of equipment, You're duplicating, multiplying those savings every single time you do that. And I will argue that most providers or most solutions today are unable to do this without a lot of industry knowledge and a lot of standards. So, calculations, priorities, all of this can be achieved once you have this structure and this solution in place. So, what does that look like in a maintenance program? So we talked about the solution. There's many out there. There's many fantastic solutions out there. It's not important. No software solution by itself is effective unless you have a very robust program to influence the users of a building. If you cannot build trust with a technical audience, if you can't get people to engage with your tool, to understand that this is a tool that's part of their process, you will not find consistent success. The only way to do that is to have a very, very good solution that provides transparency, accountability, and builds faith with the users. So, the problem in a building, everyone knows this, 30% of energy in buildings is wasted. 80% of equipment breaks before it's expected to. 40% of workers are dissatisfied with their environment. The only way to move past this is to be able to say, how can we capture information at a large scale? Now, if you look at a traditional maintenance program, you might have 900 to 1,000 checks per year. This is static checks that are occurring at incremental periods, maybe once a month, maybe once every 6 months. This isn't necessary if you digitize your equipment. And this isn't some dream future scenario. This is being done every single day by many solutions around the world. Now, the difficulty is, if I go back to the faith and building trust within the suppliers, is how do they know you're checking this equipment effectively? You have to be able to communicate that. You have to be able to transcribe exactly what you do so they understand. If you look at some control strategies, some automation solutions today, they will automatically control equipment remotely. This is fantastic, but if you can't communicate what you're doing to the technical audience, you'll quickly be ripped out of that building. Even if it's working 100% and it's effective. If you cannot allow the technical audiences to understand what you're doing and that they have faith that is the correct operation, it will not work long term. So, there's levels of this and how this goes across a traditional business. I see a solution like this being part of a facility manager, be part of a contractor in the future. But if you look at the level 0, traditional maintenance, routine-based checks, task-based checks, time and frequency. This is something that occurs in the majority of buildings. From there, the transition goes to how can I take a small amount of that time to do this check of using a tool like this. This is very obvious and very common to see this. Eventually, it gets to on-demand proactive maintenance. I no longer need to do those checks routinely. I can rely on a solution to achieve that. You still have to do statutory checks. They will always exist, but the majority of contracts have a lot of meat to be able to manipulate this. From there, you get to an operation center. I have examples of hundreds of hospitals being managed and operated out of one location by a single user. They reduce their maintenance by over 40%. This can be done today, and it's not out of reach for majority of customers. And this is on existing buildings. You have to report on the savings. This is the accountability of a solution. Energy savings is the main driver today, and they will be for a long time. I won't go too much into this, but this energy savings, CO2, kilowatt hours, this is the main business case for every user. You cannot avoid it. You have to focus on it. And you have to be transparent about it. You need to be able to look at it from a capital planning and operational planning and have an audit and stand by those numbers. You need to be able to look past into beyond energy, into maintenance, into comfort, into asset lifecycle improvement. This can only be done at scale with a very robust data model. We have an expression internally, it's called remove the red. Focusing on what's actually breaking and not performing instead of doing routine-based checks. And this is something that we implement on all our sites. Looking at critical areas, focusing effort and time on this equipment that matters, not just a building as a whole. If you're monitoring the whole building, you don't need to do routine-based checks. You can focus on what's breaking or what's important. You can go to Bill of Health and use this as a commissioning tool to make sure that your building has been set up correctly and is effective. All of these are from real live sites. None of this is mock-ups or a demo site. This is real information from real sites. What about, and there's of course huge amounts of issues that don't have costs. You can't automate everything, but they are very important. What solutions like this do is help you understand what sensors you need to install in your building to allow these cost calculations to exist. When you do capital projects, now you can start thinking, how do I ensure the future of my buildings is digital ready? And that's what you can do when you understand the use cases and the examples from what can't I do at the moment. And then of course, interoperability. So I know I'm out of time here, but it should always be, when you capture this data, it has to be able to work with other systems. No one solution is going to rule the marketplace. Everything that we do is built on, and what everyone should be doing and what the open standards should be aiming for, is built around capturing that information and making it available to anyone. So we have examples of us working with digital twin platforms, with CMMS companies, taking the critical information from our tool and embedding it in theirs. That is the only way forward. No one's going to have the single cloud to own every building, potentially. But I think the majority of users want to be able to pick the best in-house solutions and bring it into their already existing offering. There's a lot of solutions out there, there's a lot of use cases, there's a lot of capital that's been invested to make sure that these things work. And there's a lot of solutions here, I'll skip through a few of them. And then of course, the impacts. There's a bunch of studies out here where elimination of breakdowns by 75%, 45% reduction in downtimes, 30% reduction in maintenance costs, and 25% increase in production time. I've got an example where there's a big pharmaceutical company. We, in 1 year, avoided 12 deviations. Each deviation could be worth millions of dollars. They would list this as a benefit, but they would still always come back to energy savings and life cycle improvement. It's important to them, but you still have to focus on what's important to everybody. It's dollars and ROI. You have to focus on that. So I know I'm out of time, but if you have any questions, I'll be around for the next few days and happy to go through them.